So hey, I'm gonna show you how we have a scale development in the APM project. We get a lot of issues logged in for new feature requests and bugs, and we have started using agentic workflows to scale our capability to basically develop at the speed that the community is asking for. So this is how I fix bugs in batches. That's it. I summon an agent skill called batch bug shepherd that we have engineered to basically fix bugs at the scale, following a specific workflow. And another agent skill that we have put together is the APM issue autopilot. Implement the first 5 feature requests. Right, so with this skill, we can basically implement new features as in batches, right? Now, both these skills use the same autopilot engine. Let me show you a completed execution to show you what I mean. So I did another run here, a full run, right? I triggered the batch bug shepherd, and it went through the agent skill, through the process, right? I view the progress diagram, run to the table, right? It reads some assets that the skill contains, and it tells me, hey, there are 4 candidates in the issue list, and I'm gonna start triaging them, okay, to see whether it's a real bug or not, whether it's legit, right? People file bugs, but it may be disguised feature requests as well, right? So then triage gets started. And the triage happens with subagents. Here we can see how 4 different subagents were spawned. Each of these subagents uses a different model, right? So the main orchestrator is using Opus, but the subagents underneath may be using Sonnet or GPT or Haiku, whatever is more effective for the task at hand, right? So triage happens, then the agent skill, I've told it, hey, you keep me up to date with a mermaid diagram, telling me which phases have completed, and it goes on and on, then to implementation, right? It realizes that a couple of these bugs had pull requests in flight from the open source community, so then it basically reverts to looking at the pull request in flight, reviewing it, and ensuring it's mergeable, and adding any fixes directly to the pull request until we are convinced, hey, this is fixing the bug and it meets our quality and security standards, right? So then if I go down to the very bottom, we end up with a table which tells me, hey, I created a couple of new pull requests, right, ready to merge, and there are another couple pull requests that I basically ensured, hey, they are complete now, they have been reviewed, and they are ready for you to review, right? If I click on, let's say, this one here from the community, we can see how it was opened by a developer in the community, right? And then if I go to the very bottom, there is here the result posted as a comment. There were a few commits that the subagent made to basically complete the pull request or fix conflicts, whatever the review decided. Now, how did this work basically? I have here a couple of diagrams I want to show you. The first one is basically the architecture diagram of this agent skill. You can see here at the top how the batch bug shepherd agent skill contains a skill.md file and then several other files that are important for the skill, and it depends itself on another agent skill that we have called shepherd driver. It's kind of the autopilot engine. And what's important here is that this autopilot engine is used for the feature request implementation agentic workflow itself as well. So we end up with the concept of agent skills as modules, as packages that can be reused. You can see here how the shepherd driver, the autopilot engine, reuses another agent skill called APM review panel. That's the agent skill we have engineered to basically review our pull requests the way we want to get them reviewed, based on supply chain security, coding standards that we have ourselves, architecture guidelines that we have set up for the community, right? So there you go. The agent skill summoning it is super simple, right? It's just a / command, and then it guides the user through the process, right? And here we have the autopilot running to implement several feature requests. An autopilot that's reusing that same engine, right? And this is how we are scaling our agentic engineering system in the APM project. Now you may be wondering, what's the cost of all of this, right? So let me show you the completed run. The cost was $59 for fixing 4 identified bugs, right? And now the difference between these and basically prompting whatever prompt I had in mind, like fix these bugs, is that the variability in terms of cost is smaller, because this skill is already presetting the exact models I want to use. It's already engineering the process to make it cost effective, using scripts and small programs to make sure that we use inferencing only when needed, and compressing the prompts as it goes using skills like Caveman and other techniques to make sure that we reduce the costs. So through agent workflow engineering, static agentic workflow engineering, we can have better cost control, and we can make better decisions about when it makes sense to use AI for software development and when it doesn't. Thank you for watching.